asked about a proportion. So we've learned the formulas already, although I'll give it to you again. But we have our conditions. There's two that never change. Well, pretty much never change. Is it an SRS? And remember, we have to make a statement about this, especially on a test. We can't say, check. That doesn't work. It works fine if you're just checking for yourself. But when you're showing somebody, is it given? Was it stated? Is it reasonable to assume? I'll talk about reasonable to assume here in just a second. 10% of n is greater than little n, your 10% rule. Those are separate. And again, you want to put some numbers in here, and if you don't know a number like big N, which you may not know, you might say it's reasonable to assume that this population is bigger than 10 times the sample or something like that. So the example I gave in the other class is, let's say you're a biologist and you want to study the earthworms in Boise. Can you collect all of the earthworms in Boise, put them in one place, and then take a random sample of, say, 50 of them? No. You put your mind to it. Yeah, I don't think so. So if you went into your backyard and took a few shovelfuls and found your sample, then that is considered a random sample from the whole population. So there are times, another example would be, let's say you want to take a random sample of Oreo cookies. Do you have to go to every bag of Oreos in the nation or in the state or city or wherever you're looking at and pull a random sample of all the Oreos available in every store? You should, because it'd be very tasty. But no, you don't have to do that. A bag of Oreos is accepted as a random sample. So there are times when we accept that a random sample, so 10% of all Oreos in Boise is greater than the 50 in the package that you purchased, okay? And the SRS, those 50 could be a random sample of all Oreos. So there are some times where it's just reasonable to assume in both cases. Normal? Well, if it's a proportion, that's n times p is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10. Where p in this case, remember last time we didn't have p and we used p hat? This time we do. This is going to be the null. It's going to be your hypothesis p. 50% of the population thinks that the taxes should be raised. And that was their null hypothesis. We used that. So, okay.
What would be the ha in that scenario?
In the scenario that I just gave?
The other tax one.
Well, if you were wanting the tax to pass, then your ha would be greater than 50%.
Say that they should raise taxes.
Yeah, I want to raise taxes to fix the roads,
Or
right?
less than.
Right, so it costs money to take a bill to the people, right, to have an election about it. So they want to be pretty sure that they're going to win the election before they just throw it out there. At least that's how it should be done. I don't know that it's always done that way. Okay, so how to calculate a p-value?
Is that the
Yeah, you already know it.
I do?
Yeah, we learned it in 7.
Sounds like an element.
P hat minus p divided by square root of p times 1 minus p all over n. It's just standardizing. The p-value is your probability after you take this to z, and then you're going to go to table A to get your p-value.
Will P and P hat always be good?
No, not necessarily. P-hat might be something you have to calculate, like on the test the other day. 11 bags out of 98 had too much salt. What's p-hat? 11 divided by 98. So p-hat is sometimes something you have to calculate. It's x over n. Oops, there we go, x over n. You may or may not need to calculate it. But your p, what's your p? It's the null. It's the null. Yeah, it's the null. The null hypothesis, p equals, and whatever that is, that's your p. So this is your null value. Okay. And again, today we're only talking about proportions, so we keep it kind of simple. So if the p-value is less than or equal to alpha, if yes, we reject. If no, then we fail to reject.
Mr. Tiger,
Yes.
do you have an evil laugh?
I guess that depends on what my. I don't know that I do. I'd have to work on it to.
I want to hear it.
So then we make our statement. Okay. I think we get a couple of statements. We're going to do a couple problems together. You'll get the statement in that, I hope, in the examples. But let's talk about a shortcut. Got your calculators? If you press stat, then go to test. Now, there are a bunch of tests in here, and these are all tests of significance, the thing that we're actually learning right now, starting to learn. Is it a z-test? No. And it's not a t-test either, because both of these are for counts. It's a proportion test. So what we have, or what we're looking for in this case, is a one proportion z-test.
5?
And number 5. Now, will you ever find a one prop t-test?
Same thing.
No, it's not. No. Because t only works for counts, right? You have to have normal for the proportions to go.
Will we use 2 proportion tests in this chapter?
Yeah. Well, I don't know about in this chapter, but we'll get to them, I'm sure. Yeah. Yes.
So what's the difference between 1 and 2? It's 5 and 6.
Let's keep it simple right now. 2 proportion is you have 2 proportions to compare. Let's worry about that later. Yeah. You're putting too much stress on me by asking questions like that. I'm gonna have to take some time off now. All right, so let's look at a problem. Problem number 35 is on page 568. Oh, wait, no, it's not. It's farther down than that. Never mind. 35 is on page 581. I'm going to give you the statement in the example. Yeah. It's talking about home computers.
What page you said?
581. Very, Very first problem there. So in this problem it says Jason reads a report that says 80% of U.S. high school students have a computer at home. I might argue that more than that have a computer in their pocket. He believes the proportion is smaller than 80% at his large rural high school. Jason chooses an SRS of 60 and finds that 41 have a computer at home. So I'm going to write some stuff down. I think I have the null and alternative hypothesis. The null hypothesis that's given is that the proportion equals 80%, or 0.80, or 0.8. Okay. What does Jason think? That it's less than. Right. It did say that he performed an SRS of n equals 60, I think it was. And 41 have a computer at home. If n is 60, what's 41? That's your success. Success, so x. 41, success, that's his success. They had a computer at home. So it says, they actually give us some of this information that I just wrote. He would like to carry out a test at alpha equals 0.05. At a significant, that's the significance level, that p equals 0.8, we've got that versus p is less than 0.8, where p is the true proportion of all students at Jason's high school who have a computer at home. Check and see if the conditions are met. I'm going to take this problem all the way through, so I think it's actually going to be 35 and 39, I believe. You might kind of make note about that. So, have the conditions been met? Is this an SRS?
Yes.
Why? It's given, that's right. Yeah, it's given. It was stated. Is it reasonable to think that 10% of all students in this high school is greater than 60? Yeah, a large rural high school, it's reasonable to assume that it's larger than 600. What's that?
I said large. But large is all you need to know.
I think so.
Rural might be the technology.
Yes. Ah, I can spell. So if I'm answering for the AP, I'd have something like that in there. It's reasonable to assume a large rural school has more than 600 students.
That's the condition.
That's yes. So I've met two conditions. Now I need the third one. Is it normal? So I'm going to take n times p, n being the 60, and p being the 0.8. Is 60 times 0.8 greater than or equal to 10? Yes, that would be 16 if my head, or no, it's more than that. It's like 64. Yeah, anyway. And it's definitely, that's true. 48, thank you. 60 times 1 minus 0.8, that's the 16 that my head is trying to go to. It's definitely also greater than 10. So, so the conditions are met. I think it's not a bad idea to make that statement if you're planning on taking the test. They should be able to see it if you write all that out, but okay. Now let's do the significance test. So one of the things that I need to figure out is what's p hat? That's going to be x over n, which is 41 out of 60. Which is about, yeah, I'm going to go 0.683. I'm going to throw in a thousandth in there. Okay? So my calculation then is going to be p hat minus 0.80, 0.8, divided by the square root of 0.8 times 1 minus 0.8 divided by 60. Now, before you do that, let's look at that shortcut. Stat. Tests. Number 5, that's right. So, looks like I have the, maybe have the information. Oh, no, I don't. So the P, this is called P naught. This is your null hypothesis. So what's the proportion? 0.8. Oops. 0.8. My X is how many were successful?
41.
41. And he sampled 60. Now, is this a greater than, a less than, or not equal to?
Not equal to.
Incorrect. This is a less than.
The person who did this was wrong.
Well, maybe they did a different one.
The same numbers.
So it's less than the null hypothesis. He thinks it's less than the null. Color, we don't care about that. Just go to calculate, and here's what we have. So what you can get away with is writing one prop z-test proportion less than 0.8 z equals, you can do some rounding here. I'd definitely round the z to the nearest hundredth. P equals 0.012. P hat we already have. If you already have it, I don't know that you necessarily need to write it.
Makes it so much easier.
Yes, it does. However, it's necessary to know how to do this. Right? I can't just give you all computer shortcuts all your life. You can figure them out on your own.
Was there like a bunch that there is on the calculator for the last unit test? Really?
Yeah.
Oh,
Look on the test. You find anything that says interval? Look in there. If you find interval, it probably would have worked for the last chapter. So, in addition to this, I have some other stuff written that if you don't have it written, it would be important to write. Like, for example, the x value. Anything that you put into it, you'd want to write or have it written somewhere. I don't know that I necessarily needed to rewrite those two. I think if you've already got them. But by writing the one prop z-test, that tells the grader where it is that you got your values and what you've put into it, right? You need to write what you've put in somewhere and what you've gotten out. So the thing that we really care about here is this p-value. We compare p-value to alpha. Is 0.012 less than or equal to alpha, which is 0.05? Definitely, right? It's quite a bit less than alpha. So we reject.
Yeah.
That's right, we reject.
What is alpha ever going to be that large?
I think that's a reasonable alpha in this situation.
You said 5%?
It's 5%. It was given it.
12%. That's why I was confused.
Oh, the p-value is, yeah, don't read that as 12%. That's 1.2%. Yeah. So that's where we're going to compare. All we're doing is taking the p-value, comparing it to alpha. So we say we have, see if I can get this to fit in here. We have significant evidence. Because we're well within the tail. We've stepped way over the line in the sand. To what are we doing? Reject. To reject the null. and conclude less than 80% of the students have computers at home. I probably should add the students at this school, because that's specifically what we're looking at. So that is how you answer a question where you reject the null. We have significant evidence to reject the null and conclude that less than 80% of the students at this school have computers at home. Phrasing of that's pretty important.
I said the phrasing is critical.
It is, definitely. Yeah.
So then, if we fail to reject, we would just say we do not have significant evidence
Yeah.
to reject them?
You could say that, or
Or would you say we have significant?
you never say you have significant evidence unless you're rejecting the null. You never say significant, yeah, you never say it's, you wouldn't say I have significant evidence to fail to
Right.
reject. That doesn't make sense. Yeah. Yeah. I think the next problem, actually, the next example, we'll try to make it a little bit shorter, is 51. Oh, no, that's not a fail to reject. No, you know what? I think I'm just going to hush up now. You guys have asked some really good questions. Give 51 a try on your own. But as an example, let's say you have a fail to reject. You could say something like, I'm thinking about the fail to reject statement. We do not have significant evidence, so we fail to reject the null, so we do not have there we go. Actually, I'm going to scratch that. I want to phrase this one. It's been a while since I've phrased one of these. I apologize. I should have been a little more prepared. I'm trying to put it in the context of the computers. There's not a significant difference, or better yet, there is not significantly less students that have computers at home.
So you would say difference, what is it?
If it was a not equal to, yeah. Yeah, there's not a significant difference, or there's not significantly more or less. In this case, it'd probably be there's not significantly less, yeah, than the 80%, right? Exactly. But we fail to reject. So you do not have significant evidence. If you reject, you do have significant evidence. Even if you're concerned about an error, you still reject or fail to reject based on the numbers, not on the concern about an error. Okay? So, give these a try. I'll come around and help out. Peyton? Yeah?
Oh, that worked.
Oh, okay. I'll come help you in just a second. Did anybody